This is a review video of expectation. So if you're given a distribution and you can only get one number to summarize that distribution, a very good number to request is the expectation, or also sometimes known as the mean. It may lead you astray, but oftentimes it tells you a very good part of the information distribution, especially if you actually then look at the numbers themselves. So let's start by reviewing the definition. The expectation of a random variable x, and this is the discrete random variable x, is the summation for all little x in the range of the random variable x times the probability that random variable x takes on the value little x. So it's a summation over all little x in the range of the random variable x of little x times the probability that the random variable x takes on the value of little x. So let's discuss an example. So consider that we're going to roll a fair die. So let x be the value on the face of the die. We're going to calculate the expectation of x. So the first thing we want to consider is what is the sample space. And this sample space is also going to be the range. So the possible values that the face of the die can take are the numbers 1 through 6. And we want to consider the probability of the random variable of each of these. And since it's a fair die, we know that each of these are going to be 1/6. So the probability that the face of the die is I is going to equal 1/6 for all I between 1 and 6. So now we're just going to calculate this expectation. So the expectation of x is going to be the sum of 1 times 1/6 plus 2 times 6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6, and finally 6 times 1/6. Okay, so now let's simplify this. So we know that we can pull out 1/6, and then we're just taking the summation as I goes from 1 to 6 of I. And we know what the summation is. We know that's 6 times 7 divided by 2 times 1/6. So we know that our expectation is 7/2 or 3.5. Now we're going to consider another example. In this case, we're considering the roll of a die again, but this time the die is not going to be fair. Instead, it's going to be weighted toward the even sides of the die. So as with before, our sample space is still 1 through 6, and that is also the range of x. But the only difference is that now our probability is going to change. So in this case, the probability that x equals I is going to be 1/4 if I is even, and 1/12 is I. So now let's do the exact same calculation for this case. So we know it's going to be the expectation of x is going to equal 1/4 times all the even faces of the die. So that's going to be 2, 4, 6, plus 1/12 all the odd. 1 plus 3 plus 5. Okay. So So this is 12, so we know that this is 3. And this summation is 9, so 9/12 is 3/4. So now we have 3 and 3/4. And now we're going to do one more example of applying the expectation. And this example is called the birthday paradox. And in the birthday paradox, we have a room of n people. So we have this room of n people, and we want to know how many pairs of people share a birthday. What's the expected number of pairs of people that share a birthday? So rather than worrying about the joint distribution of the birthdays of the people in the room, we're going to use indicator variables in that we're going to have an indicator variable that is going to say whether a pair of people share a birthday or not. So to be more precise, we're going to set let our indicator variable I sub j be 1 if pair j shares a birthday and 0 otherwise. So now, in order to figure out how many pairs of people are expected to share a birthday, we're going to find another random variable, s. And s is going to be the random variable for the number of pairs of people that share a birthday. And this is just going to be the sum over all of our indicators for each pair. So we have our ij, these are our indicators, and our indicator variables, the total number of pairs we're going to have is j is going to go from 1 to n choose 2, because n choose 2 is the number of pairs that are possible in a room of n people. So now we want to consider what the expectation of s is. So the expectation of s is equal to the expectation of the sum of these indicators. Well, the nice thing that we can apply now is the linearity of expectation. The linearity of expectation, which we can apply all the time, we don't have to worry about anything like independence, says that the expectation of the sum is the sum of the expectations. So we're taking the sum, as j goes from 1 to n choose 2, of the expectation of the indicator variable for the pair. Now, this equality here is by the linearity of expectation. Okay. So the nice thing that we can use now is that when we're taking the expectation of an indicator variable, in this case the indicator variable that pair j shares a birthday, the important thing to remember is that the expectation of the indicator variable is just the probability of the event that it's indicating, in this case the probability that pair j share a birthday. I'll be more clear about this in 1 second. We can show this clearly. So let's just calculate this once so we can be convinced of this. So the expectation that the indicator variable ij is equal to the probability of the pair j sharing birthday is just 1 times the probability that pair j share birthday probability that pair J not share its birthday. See, this will just go away, and then we're left with just the probability that pair J share a birthday. Since there's 365 days a year, we know this probability is just 1 over 365. So the expectation that the pair shares a birthday is just the probability that they share a birthday, and that's 1 over 365. So when we go back to the expectation of S, the number of pairs that share a birthday in a room, we can see that this is just n choose 2, because we have n choose 2 pairs of people and n choose 2 indicator variables. And then the expectation of the indicator variable is going to be the same for all pairs, and we just showed that that expectation is 1 over 365. So this is just n choose 2 divided by 365. And that is the expected number of pairs of people in the room that share a birthday.